Okay, now that we have our booklet put together, let's open it up and let's look at the Exponent Rules Quick Reference. The very first thing that we want to note, when I am adding and subtracting anything, I need to make sure that I am simply combining my like terms. Okay, so I'm going to write in here, combine like terms. And sometimes with our exponent rule stuff, we have multiple variables. We have to remember that those variables have to be exactly the same. So I'm going to make a note here also to keep my variables the same. Okay? Now, to review the rules that we've talked about multiple times, what we're going to do, if I have something like x to the a power times x to the b power, remember I'm multiplying two things together that have the same base, so I'm going to add their exponents. So x to the a power times x to the b power is x to the a plus b power. Whereas the quotient rule, if I am dividing two things that have the same base, I'm going to subtract their exponents, keeping the numerator's exponent first, and from it, I'm going to subtract the denominator's exponent. Then we have the power rule. Okay, if I have x to the a power and it is raised to the b power, I'm simply going to multiply a times b. Okay, and also, I want to be very careful to remember that if I have x to the a power divided by x to the b power, and I have an exponent out here, let's say c, I'm going to make sure that I distribute that right here. So x to the a times c over x to the b times c. And if I could simplify that in the end, that would be very good to do. All right, the negative exponent rule. If I have anything raised to a negative exponent, so x to the negative a power, I want to remember, although it is not written, I need to remember that there's an understood 1 out front being multiplied, and this negative exponent only belongs to that variable. So I want to keep the 1 in the numerator, and I'm going to drop the x to the a power to the denominator. Or vice versa. If I have 1 over x to the negative a power, I'm dealing with a negative exponent, and I don't want that, so I'm going to move it to the top. So then this would end up being 1 times x to the positive a power. All right? And then last, anything raised to the 0 power is equal to 1. So it doesn't matter if there's parentheses or if it's just a variable. Anything raised to the 0 power is 1. Okay, so what we're going to do, I'm going to work through several of these with you. In this booklet, you'll notice every problem is numbered, okay? There are a total of 65 problems in this little booklet. I'm going to do several of them with you, okay? Over the next couple of days, you're going to be working to complete this. So I'm going to kind of skip and jump around a little bit, working problems that I think might help you complete the remainder. So please make sure that you are paying attention. Don't jump ahead. You will have a full day of class time to work on this, and it will be due in a couple of days. So let's start off right here on the page that says product rule. All right, so my product rule right here, I'm going to remember if I multiply two things together and they have the same base, I'm going to add their exponents together, okay? So let's start here with number 1. We tend to get a little confused sometimes when we're working with numbers. Pretend this is an x. I'm still not going to change my base, okay? So I'm going to keep my base the same. I'm multiplying 3 squared times 3 to the 6th. I am multiplying those two bases together, so I'm going to add their exponents. Now I am going to show my work, and that is my expectation for you as well, okay? Now, since I'm working with numbers here, I'm going to go ahead and I'm going to raise 3 to the 8th power, and that gives me 6,561. All right, and that would be my final answer. So I'm going to put a box around my final answer for every single one of my problems. Okay? Right here. Let's go to number 3. I'm dealing with variables. My variables are the same, so I'm going to add their exponents since I'm multiplying them together. And I simply get x to the 5th power. Now I cannot simplify that in any way because I don't know what the value of x is. So that's it. Okay? Let's jump over here to number 10, please. Okay? Notice I've got numbers, I've got multiple variables going on. So what I'm going to do, I am going to multiply my numbers together. -2 times -9 is positive 18. And then I'm going to combine my r's. I have r to the 6th power and r to the 3rd power, and they're being multiplied together. So I'm going to add the 6 and the 3. Okay? Then I'm going to work with my s's. I have s squared on the left, and it's being multiplied by s squared on the right. So 2 plus 2. And then right here, we need to remember we have an unwritten 1 as the exponent for t. So I'm going to work with my t's. Right here I have t to the 1st power and t to the 4th power. So I'm going to combine those. So I have 18 r to the 9th power, s to the 4th power, t to the 5th power. And that is simplified as much as it possibly can be. Okay? All right, and then number 11, I want you to pay attention to the fact that I'm multiplying things right here together, and then it's asking me to add something. Remember our order of operations. Multiplication comes first. So I'm going to start right here, okay? I've got -8 times 5, which is -40. There's an understood but unwritten 1 as the exponent for x. So that's going to be x to the 1st power times x to the 3rd. So I'm going to add the 1 and the 3. And then putting my y's together, I'm going to add the 3 and the 2. And then out here in the back, I still have this 3x to the 4th, y to the 5th power. All right, so right now I have -40 x to the 4th, y to the 5th power, plus 3x to the 4th, y to the 5th power. So I've gotten this first part simplified. I need to check and see if I can even add these two together. In order to do that, I have to have the exact same variables with the exact same powers. So I have x to the 4th, y to the 5th for both of them, so I certainly can. I'm going to take -40 and I'm going to add 3 to it. -40 times 3, or not times 3, plus 3 is -37, and then I have x to the 4th power, y to the 5th power. And that is my final answer. Okay? Now right here, notice on number 12, I'm not going to work this whole thing with you, but I want you to pay attention. There's a whole bunch of multiplication going on right here, and then there's some subtraction, and then there's a whole bunch of multiplication going on in the back. So even though they're not written there, I need to understand there is some understood grouping that has to happen, because right here, multiplication comes before addition or subtraction in the order of operations. So I'm going to group all this stuff that's being multiplied together in the front and in the back, simplify what's inside the parentheses, and then determine if you can combine like terms, okay? All right, moving to the quotient rule. Moving to the quotient rule. This is where if I am dividing two things that have the same base, I'm going to subtract their exponents, the numerator minus the denominator, okay? Let's look at number 14. I think number 14 is a good one to do because we've got some parentheses and a negative inside the parentheses. There's an understood but unwritten 1 as the exponent right here. I'm going to keep my base the same. Now my base is -2, so I'm going to leave it in parentheses, and I'm going to do the numerator minus the denominator's power. So that gives me -2 to the 4th power. Okay, sorry that's sloppy. Right here around my staple. Okay, now in my calculator, I'm going to make sure that when I when I raise that -2 to the 4th power, I'm going to make sure that I keep it in the parentheses that I have here. So when I raise that to the 4th power, I ended up with +16. Okay, and that's what I got for my final answer. The only reason I did that was because I'm working with numbers. All right, let's look here at number 17. Number 17, the R and the S in the denominator have an understood but unwritten exponent of 1. So I'm going to combine my R's and I'm going to combine my S's. Okay, I'm dividing, so I'm going to subtract their exponents. R, the 8th power in the numerator, minus the 1st power in the denominator. And the S, 3 minus 1. So then, that gives me R to the 7th, S squared. There's nothing else I can do because R and S are different variables. You cannot do anything else with those. Okay? Let's look at number 22. Number 22 is a little difficult, but what I'm going to do, anytime I have a fraction, I'm going to put grouping symbols together right here around the numerator. I want to do as much as I can in the numerator before I do anything vertically. Okay, now right here it's kind of hard to see, but there is a dot which indicates the multiplication. So I am multiplying 7 times -6. 7 times -6 is -42. I'm going to put my C's together. So I have C to the 6 plus 2 power. And I have D to the 2nd plus 1 power. Remember, there's an understood but unwritten exponent of 1. Okay, and that's still over -3 C to the 7th D squared. All right, so I'm going to simplify this real quick. I need to write small because I'm running out of room. This is going to be -42 times C to the 8th D to the 3rd over -3 C to the 7th D to the 2nd. Okay, now right here, -42 divided by -3 is +14. c to the 8th divided by c to the 7th. 8 minus 7 is 1, so that's simply going to be c to the first power. I do not have to write that 1. And then I have d to the 3rd divided by d squared. So 3 minus 2 is also 1. So I'm going to leave this just like that, and that is my final answer, 14CD. Okay? All right, and then I'm also going to work number 23 with you, okay? So right here, I'm going to simplify what I have up in the top. I'm going to put my imaginary parentheses right here. This gives me 4 times 10, so that's 40. W squared and w to the 7th. W squared, 2 plus 7 is going to give me 9. V to the 3rd power and v squared, 3 plus 2 is going to give me 5. Okay, and that's going to go over negative 5, w, v to the 4th. And then out in the back, I have plus 14, w to the 8th, v. So I'm going to start by simplifying this. I have 40 divided by negative 5. That gives me negative 8. Remember, there's a 1 right here. W to the 9th divided by w to the 1st. 9 minus 1 is 8. So w to the 8th. And then right here, 5 minus 4 is 1. So that's v to the 1st power. I do not have to write that. And I have plus 14 w to the 8th v. Remember, if I'm going to add these two terms together, I have to make sure that I have the same variables and the same powers. Both of these have w to the 8th v, so I know I am good, okay? Now I know that negative 8 plus 14 is 6. So this is going to give me 6w to the 8th v. And that will be my final simplified answer. Okay? Now, the only thing that I'm going to help you with on number 24, in the top of my fraction, I want to put this stuff together. Notice right here, I've got the same variables and same powers, so I can go ahead and simplify that. Then you would simplify the fraction. But over here in the back, I've got some multiplication going on. I've got addition and multiplication. Multiplication comes first. So if I were you, I would simplify all of this in this big fraction before I add it to whatever this is simplified. Okay? And that's the quotient rule. The power rule. Okay, the power rule. If I have a power raised to a power, I need to remember that I'm going to multiply those exponents. Okay? So let's start out. We're going to look at number 30. So remember, this exponent of 3 belongs to the negative 2, the x, and the y. And anytime I am working with two powers like this, I will multiply them. I chose to do this one with you because of this negative 2 right here. I want to be very careful to protect the negative 2. So I'm going to keep that negative 2 in parentheses, and I'm going to raise it to the 3rd power. Then I have x to the 7th power, and it's going to get multiplied by 3. And y to the 5th power times 3. Okay? Now, be very careful again when you go to plug in this negative 2. Please make sure you keep it in parentheses and then raise it to the 3rd power, because that's going to affect my sign. Okay? Negative 2 cubed is negative 8. 7 times 3 is 21. And 5 times 3 is 15. There is no more simplifying that can be done there. So that is my final answer. okay? All right, let's look at number 32. I chose number 32 because of this fraction. I know we love fractions. I'm just kidding. Okay, but I do want to take this 2 and distribute it to the 1/4, the A, and the B. So again, I'm going to protect my fraction, and I'm going to put my fraction in parentheses. Okay? I've got A to the 8th times 2 power, and that is B to the 4th times 2 power. Okay? Now remember, this 2 belongs to the 1 and the 4. So 1 squared remains 1. Okay? 2 squared, or I'm sorry, not 2 squared, 4 squared is 16. So notice I have a fraction. This is like me saying 1/4 times 1/4. We multiply fractions straight across, so it makes sense that 1 times 1 is 1 and 4 times 4 is 16. I have 8 times 2, which is 16. So I'm going to take A to the 16th power, and I'm going to write it in the numerator, okay? And then 4 times 2 is positive 8, so I'm going to have B to the 8th power in the numerator. Now, I want to clean this up a little bit, okay? I'm going to extend my fraction bar. Right here, I don't need the 1. It's understood, so I don't really need to worry about writing that out, okay? The only thing I'm going to do here, I'm going to erase this 16, and I'm going to move it over so that it's centered just a little bit more underneath those 2 variables. Those 2 variables remain in the numerator because their exponents are positive. So A to the 16th power, B to the 8th, divided by 16 is my final answer. Okay, let's look at number 36. I want to do that one with you, okay? All right, so right here, I am going to look at the numerator. There's nothing happening up here that I can simplify. So I'm going to focus on my denominator, okay? Right here. I am going to distribute, oh, hold on just a second. I want to point out that there is a -1 out front, okay? So when I distribute this 3, it goes to the -1, the M, and the N. So right here, I'm going to keep this 24, M to the 8th, N to the 5th. I'm going to keep it in the numerator. Then I've got -1 that gets raised to the 3rd power. Notice, again, I'm protecting that -1. Then I have M. I have 2 as my exponent times 3. 2 times 3 is 6. And then right here, this has an understood but unwritten exponent of 1. The N does. 1 times 3 is 3. And then to that, I'm going to add 5 M to the 6th, N to the 3rd power. Okay? And then out back, I'm just going to copy down what I have for right now. Okay? I really only like to work one thing at a time so I don't get lost in it. All right. Be careful with my -1. I shouldn't need a calculator for this, but I just want to show if you do check it with your calculator, protect the -1 with parentheses, and that gives me -1. So I'm going to rewrite this again, okay? Actually, are you okay if I just cross this out kind of like I did imaginary numbers, and I'm just going to put a -1 out front? All right. Right here, I have -1 M to the 6th N cubed plus 5 M to the 6th N cubed. I have the same variables and the same powers in my denominator. Right here I have 24, whoops, I left out the 4. 24 m to the 8th, n to the 5th. All right, negative 1 plus 5 is 4. And if I'm just combining like terms, I do not change anything with my exponents. Okay? So now I still have to deal with this square that's out here. Now I'm multiplying this. Anytime I have something like this, please understand that I can write that as a fraction over 1. Negative 3 squared, negative 3 times negative 3 multiplied by itself 2 times is positive 9. There's an understood but unwritten 1 right here, so 1 times 2, that's going to give me m squared. And then 4 times 2 is 8, so n to the 8th. Okay, so right here, I want to put everything together that I can. I'm going to multiply straight across. Okay, 24 times 9 is 216. I'm going to carry on the next row. 216, m to the 8th and m squared. I'm multiplying two things together that have the same base. So 8 and 2 are going to be added. So that's m to the 10th power. And then I have n to the 5th times n to the 8th. So 5 plus 8 is 13. That has combined my numerator together, okay? And in my denominator, if I multiply this by 1, nothing changes. So I'm just simply going to copy over 4 m to the 6th, n to the 3rd. Now I have one more step, okay? This seems like a lot, but I want to check in real quick, and I want to see if 216 is divisible by 4. I got a pretty number, 54. So that is going to go right here, okay? Then I'm going to work with my m's. I'm dividing two things that have the same base, so I will subtract their exponents, okay? I have m to the 10 minus 6. 10 minus 6 is 4, so that's the 4th power. And then simplifying my n's, I have 13 minus 3, so I end up with 10. There is nothing else that I can do to this one finally. Okay? So that would be my final answer. Okay, let's flip this to negative exponents. My rule for negative exponents, if I have a negative exponent, I'm going to cross the fraction bar line and change the exponent sign. But if I start out with a negative exponent, then I can just bring it up to the numerator and it turns positive. Okay? So let's start with number 39. I want to remember that there's an understood but unwritten 1 out front. This negative 5 only belongs to the x. So I'm going to leave the 1 in the numerator, and I'm going to drop the x to the 5th to the denominator. I want to cross the fraction bar line to change the exponent's sign. Okay? Number 40. All right, notice right here, I have a Q and I have a P. Since these do not have the same base, I cannot combine them. However, I notice that down here in the denominator, I have a negative exponent, and I am not allowed to have that. So I'm going to bring it up to the numerator, and that is going to give me Q to the 4th, and then P squared is simply going to go right next to it. And that is all. okay? Let's look at number 44. Number 44, right here, I've got numbers being multiplied together, and I've got like variables that I will put together, and then I see some negative exponents, so I may have to move them around in the end, okay? To start out with, negative 2 times 3 is negative 6. And then I'm going to put the p's together. I have p to the fourth, and to it I'm going to add a negative 3. Okay, that looks funny, but I'm still adding my exponents. I have q to the negative 2 power, and to it I'm going to add a negative 4. Okay, so let's simplify. I get negative 6, p to the first power. Technically, I don't have to write that one. I'll simplify that in a moment. And then I have q to the negative 2 plus negative 4. So that's going to be q to the negative 6 power. I realize that this leading coefficient is negative. I don't care about those negatives. I only care about the negative exponents. Okay, I've got a negative exponent here, so I want to drop it to the denominator. Okay, so I'm going to keep the negative 6 and the p to the first power in the numerator, and I am going to drop q to the negative 6 power down to the bottom, so that makes this a positive 6. That is my final answer. Okay? All right, right here, let's look at number 48. Number 48. Notice I have a 20 and I have a 12. I have some G's that I can put together and some H's that I can put together. This G up in the numerator has an understood but unwritten exponent. All right, and what I want to start doing right here, I want to look at 20 over 12. Right here, these do not divide evenly into each other, but there are some common factors that I could divide out. 20 and 12 have a common factor of 4. So if I divide out a 4, that leaves me with 5 here and 3 here. 5/3 cannot be reduced. So I'm going to leave 5/3 out to the side. I'm going to write it as a single fraction for now, and I'm going to work with the G's and the H's. So I have G to the first minus the negative 1 power, cutting it a little close right there, and I also have H to the negative 4 minus 2 power. That was not a negative 2, so I don't have to have my parentheses, okay? Now, we know that double negatives are going to turn positive. So I end up with right here 5/3 G to the second power, because 1 plus 1 is 2. And I end up with H, let's see, negative 4 minus 2 is negative 6. Because this G to the second power has a positive exponent, I'm going to put it up in the top of the fraction with the 5. And because this H has a negative exponent, I'm going to drop it to the bottom with the 3. Okay? So I have no more negative exponents. I am good to go. And that is my final answer. Okay? And let's look at number 49. Sometimes I may have a negative exponent that I have to distribute, but I do not want to move anything around until I multiply everything together and I see what I've got in the end. So this negative 2 belongs to the R and the S. So raising a power to a power, I need to remember that I am multiplying. So I've got negative 3 times negative 2. And I have S to the 5th times -2. So -3 times -2 is +6. And 5 times -2 is -10. The only problem I see is this negative exponent right here, s to the -10 power. We do not like negative exponents. Whoa. So I'm going to drop the -10, s to the -10, to the denominator so that it creates a positive exponent. So r to the 6th power divided by s to the 10th power. Okay? All right, let's move on to some of the let's move on to some of these right here, okay? Let's move on to more practice. All right, let's look at number 52. Okay, again, I chose this one because of the fraction. I know we don't like fractions very much, but I don't want them to overwhelm you, okay? So right here, I could, I need to start out with distributing this 2, okay, the exponent on the outside of the parentheses. So I'm going to protect my -4. That's -4 squared. Power to a power, I'm going to multiply. So 3 times 2 is 6. And 2 times 2, b to the 2nd, times 2 is 4. Then I'm going to multiply that by 1/2 a cubed b. Now, I could write in the 1 for the exponent there if that's helpful, but I certainly don't have to. Okay, I also know right here that -4 squared is 16. So very quickly, what is half of 16? Half of 16 is 8. All right, then I can put my a's together. If I am multiplying two things together with the same base, I've got a to the 6th and a to the 3rd. I'm going to add their exponents. So 6 plus 3 is 9. And then I'm going to work with the b's. I have b to the 4th and b to the 1st. 4 plus 1 is 5. Okay? So that right there is as simplified as I can get it, and I am good to go. All right? Let's scoot over to number 58. Number 58. Right here, okay, I have some subtraction that's happening, but I cannot do subtraction until after I have simplified this front fraction, okay? So right here, I'm going to start by dividing 32 by -8. 32 divided by -8 is -4. There's an understood 1 right here. I'm dividing two things that have the same base, so I'm going to subtract 1 minus, and then that's a -2 right here. And then I have b to the 4th power minus the 1st power. Okay? Now I can't fit all that other stuff, so I'm going to simplify this and then I'll drag this down in a minute. So I have -4. This double negative right here is going to become positive. So 1 plus 2 is 3. And then 4 minus 1 is 3. And then I'm going to drag down the -3 or -3, a cubed, b cubed. Checking, I've got the same variables and the same powers, so I can combine my like terms. -4 take away 3 more is -7. So I have -7 a cubed, b cubed. And that is all I can do to simplify problem number 58. All right? Now do me a favor and flip over right here to the very back, okay? Now, it says, find the perimeter of the rectangle. If I'm finding the perimeter, this is where I add up all of my sides, okay? Now, right here I have 3a squared b, and I know that this side is going to be the exact same thing. So these two pieces, if I mark it like I did in geometry, those two pieces are congruent to each other. And then right here, this 7a cubed b is going to be the same as this side over here. So these two sides are congruent. One quick formula for the perimeter of a rectangle is 2 times the length plus 2 times the width. Now I'm going to call the sides that I marked purple my length, and the sides that I marked pink my width. All I am going to do is substitute those values or those expressions in. My width is 7a cubed b. All right, to make this as easy as possible, all I am doing is multiplying the 2 times the 3. So that is 6a squared b plus 2 times 7 is 14a cubed b. Quick question. When I am adding these two things together, we have to make sure that they have the same variables and the same powers. My problem here is that a on this term has a square and a on this term has a cube. So therefore, they are not alike and I cannot put them together. Okay? That makes this my final answer. Okay? What I've got right here, this is my perimeter. Cannot do anything more than that. All right, find the area of the triangle. Well, first of all, the area formula for a triangle is half times the base times the height. Notice I've got all three sides right here. So let's find the area. Now, I'm only plugging into 2 of these things. I'm plugging into the base and I'm plugging into the height. I need to look very carefully for the 2 sides that form the right angle, okay? The base would be right here. I'm going to let 13x squared y be my base and 6xy be my height. Notice these 2 sides together form my right angle, okay? So I'm going to substitute those values into my formula. Half times the base times the height. The base is 13x squared y, and the height is 6xy. This is just me. If I can't immediately take half of that first number, I'm going to work with the expressions that are back here in the back. I'm going to put those together, and then in the very end, I'll deal with the 1/2. So 13 times 6, I'll check with my calculator. 13 times 6 is 78. So right now I'm working with half of 78, and then I have x squared, and then I have an x over here, but that's x to the first power. So I'm multiplying 2 things together with the same base. 2 plus 1 is 3. Here, both of these y's have the first power, so this is y to the first times another y to the first. 1 plus 1 is 2. And the last thing that I'm going to do here, I'm only going to take half of this number, okay? I don't want to do anything to my exponents. So 78 cut in half is 39. So the area of my triangle is 39 x cubed y squared. Okay, nothing more than that. I wasn't given any units, so I don't have to worry about any of that. Okay? All right, and then lastly, for my trapezoid, okay, the area of a trapezoid, I want to write my formula right here, okay? This is not one that we typically know, but I have 1/2 the sum of my two bases, so base 1 and base 2, times my height, okay? Base 1 and base 2 times my height. Now, I am going to let base 1 be pink, and it doesn't matter which base it is. The bases are the two sides that are parallel to each other. I'm going to let base 2 be purple, and then I'm going to throw in blue for my height, okay? And my height, again, comes from a side that forms a right angle. So I'm simply going to plug in what I've got, okay? Now, base 1, I called 9 m to the 5th power n squared, and I'm going to add it to 17 m to the 5th n squared. Got a little tight right there too. And then in the n, I'm going to multiply it by 5n cubed. All right, so I want to start right here in my parentheses where I am adding these two things, okay? I have m to the 5th n squared for both of them. So I'm going to start right here. I've got half of 9 plus 17 is 26. And I'm going to keep the variables and their powers exactly the same, okay? And then in the end, I'm going to multiply that by 5n cubed. Now what I see right here is that I can multiply these two things together. I can do half of 26. Half of 26 is 13. So this becomes 13m to the 5th n squared. And then I'm going to multiply it by 5n cubed. So, last step, okay? 13 times 5. I'm going to grab my calculator. 13 times 5 is 65. M to the 5th, there's no other m to combine it with, so it's going to remain m to the 5th power. And then n squared and n cubed, I'm multiplying two things together with the same base. So I'm going to add their exponents. 2 plus 3 is 5. And that is my final answer for the area of my trapezoid. Okay? So, right here, you have just been led through, I believe, like 21 problems out of the 65. Your task is to complete the remainder of this booklet, okay? You need to work very, very accurately. Make sure you show enough work, okay? You'll notice that as I ran out of space, I did cut showing my work short just a little bit, but there's at least enough so that you can follow what I'm doing. So, your job, you are going to make sure that questions 1 through 65 are complete, okay? If they are not complete, it will count against you. So work very hard to get this right. If you have questions, please let us know, okay? Thanks.